So, next thing I'm going to go over, which is like kind of one of my favorite components to work with, they're so interesting, is an inductor, which is pretty much just a coil wire. Yeah, pretty much that's what it is, just a coil wire. And what it does is that it fights the change in current. So the equation for inductor, usually we have as L in equations. L is going to equal the number of turns squared times the the constant of the permeability of whatever you have in there. Like, let's say in the loop you put some material in there, this is going to be your permeability, and then permeability of free space, which is 1.226 times 10 to negative 6 Tm over A T. All of the times the area of, the cross-sectional area, like between the loops of the loop, over the length of the coil. And we measure these in henries. So in a circuit diagram, this is pretty much what it looks like. Yeah, it's very simple. And if we look at a timetable, it's almost like a capacitance. Capacitor is their timetable, except as to do with current over time. So we see here that current is increasing, and once this gets to a current that doesn't like, it starts to fight it back and stabilize it at some point. And these are also used. These things are very useful for things such as transformers, inductance, let's say, also what's called harmonic circuits. So in series, these guys act just like resistors. You have L1 plus L2 when they're connected this way, and parallel when they're joined up together, just like a resistor. L1 times L2 over L1 plus L2 equals LEQ. And to find voltage, voltage is equal to L times the change in current over the change in time. So this kind of looks familiar. It kind of looks like the same way you would find current when you're given capacitance and the change in voltage over change in time. So when we find I of t as a function of t, that's going to equal 1 over the inductor, value of the inductor, times the integral from 0 to sometime t, v of d tau plus I plus I of 0, when I of 0 is equal to the original value you're looking for. Actually, this should be t of 0. It's t of 0 just for the example.